Thank you so much for the kind introduction, and good morning, everybody. Well, I'd like to take a minute to also introduce Kim, who's here with me today. And Kim has received her master's in the sustainability program at RIT, and she started with us last October, and she's done a lot with LCA as well. So we hope that you'll get a couple key things out of this presentation. Primarily the why. Why should we care about the LCA? What is the LCA itself as a tool, and how can you maybe use it? But also, life cycle thinking, I think, is one of the critical components of this whole presentation. So each of you, we don't have a chance to kind of go around and see what your business is and what you do day to day, but if you can incorporate the life cycle thinking approach, even if you never use LCA as a tool, that in itself will benefit the work that you do in any production area or any type of manufacturing area. So those are the three pieces that hopefully at the end we can really talk about. So I just want to take a minute to, I don't know if everyone knows who the Pollution Prevention Institute is, maybe? I know we've come a couple times, but just at a very high level. So basically we have an opportunity to work on really great projects and help New York State companies, communities, and we actually work with academia as well. Our focus has been on pollution prevention, sustainability, green engineering. We have a team of 12 people, engineers and scientists back at RIT, but we're responsible for New York State. So we actually receive money from the New York State budget, from the Environmental Protection Fund, to be a technical resource and providers for New York State companies. So it's been a really neat 6 years, and it's really, I've loved this position. It's been wonderful. I work with a great team. We got to see companies all throughout New York and really make some great changes, and I'm really going to miss everyone here as well. So. But this is a big state, and we're partnered with 4 universities. My alma mater is Clarkson, so we're actually partnered with them as well, but also great schools, UB and RPI. So I know Ryan's not here today, but we're hoping we can actually host our student competition, which is always on Earth Day, at UB next year, so that would be pretty exciting. High level, we have 7 programs that we've actually carry out regularly, and on a very high level we have an R&D program so that professors can work in the field of sustainability and pollution prevention. But what's exciting about that is they work on very practical research. So they actually partner with industries to try to understand where the gaps are in New York and to actually be able to make real changes. We have 3 primary programs where we actually work with companies. The direct assistance program is where we do a lot of boots on the ground engineering, where we work with manufacturing processes on reducing costs and reducing environmental footprint. And then these 2 are actually very exciting programs in the sense that they were kicked off a few years ago. So sustainable supply chain is actually what Kim is working on primarily with Trish Donahue, and the idea there is to really help the suppliers in New York become more sustainable. So if they're looking at meeting scorecards or some type of certification that's going to help them become more competitive and more marketable, we can help them get there. And then green technology acceleration has been really fun because we've had a chance to work with companies that really focus on wanting to provide green technologies to New York State, but also, to commercialize them. And how do you do that? What does it really mean to be green? Are you really going to put out a green product, or are you going to get a lot of flack from your competitors because you're greenwashing? Actually, with the Green Technology Accelerator, that's where we've carried out life cycle assessment. So that's a tool that you can really use to help quantify the environmental benefits of your product. And when you actually market your product as being better in some way, you have the data to back it up. So that's really where we're using LCA at the P2I. We do trainings like this, and I hope I get to do more of these because these are fun, and we have some other sector projects. But today, again, the goals are to really give you a sense of LCA, life cycle thinking, why is it important, and talk about it a little bit through the supply chain. So with that, we'll start with Kim.
Thank you for having us today. Again, Anahita mentioned my name is Kim Bodden, and I just wanted to mention to you that I originally come from manufacturing. I spent 8 years in the manufacturing arena in electromechanical environment, and so I truly appreciate the challenges that manufacturers have in showing and measuring their environmental benefits. Some of you may have seen this in the past, perhaps with Trish's, some of Trish's, is that better? Okay. Presentations. We're showing the life cycle interactions of a product system. Up on the upper right, we have the supply or the life cycle of a product from resource extraction, such as fuel or anything that comes out of the ground from the earth, to the supply chain, and this one in particular shows a food manufacturer, and to the end consumer. Along the life cycle, however, each one of those life cycles uses transportation. They use fossil fuels, they use packaging, energy is used, and the production of energy is required, and then you consume that energy, as well as water and other natural resources are consumed by each of these life cycles, and at the end, we have the end result of wastewater and pollution and emissions and solid waste, for example, and our future generations have to deal with that. Over the last few years, suppliers have become required more by the public and customers to become more transparent in their supply chain. The public is more aware of these environmental impacts, whether it be environmental impacts or even social impacts. Social media lets the public know what companies are doing, and it's becoming very important for companies to show how they're showing their environmental stewardship, how environmentally impacting are their products. I want to talk about a few different ways to put this into context, the different ways that companies are doing this. Some companies may go through third-party certification, whether it be an ISO 14001 or other third-party certifications. Companies may measure, even within their own company, their energy usage. I'm sure a lot of you are looking at that energy usage, solid waste, recycling, things that you have direct control over. These types of labels, called environmental labels, are defined by the International Standards Organization, the ISO Institute, and they define them into 3 different types. Some of you may be familiar with this. Type 1 are called eco-labels, and there's a specific standard that goes along with each one of these. So eco-labels are recognized by having life cycle considerations. There's multi-attributes within these that companies are evaluated on. There's a third-party certification, and products are evaluated. Products don't just receive the certification, they go through an evaluation process and only get the certification if they meet them. How does this help the company? It helps the company be more transparent to the public. Consumers don't have to be as educated. They can put their trust. They see a label. Now I put these labels up here because we're doing a recent project with a cleaning product, but you may be familiar with, there's many others. On the Eco-Label Index, there's over 435 eco-labels on there that can be evaluated. These in particular, we are looking at cleaning products. You may be familiar with those. But consumers can trust that this tells them that there's been life cycle considerations and that product meets a minimum requirement. The second kind are green claims. They're self-declarations by a company. And there is a standard, a standard that companies can go by to do this. The risk is, there is a risk here in that you're not third-party certified. So there is a benefit of having that third-party certification in any way. And there could be a risk of greenwashing. The customer is putting their trust in the company that they're really doing what they're saying they're doing. And lastly, some of you may have heard of environmental product declarations. They fit into a Type 3 environmental impact label. And an environmental product declaration uses life cycle assessment as the tool to quantify those environmental impacts. This really gets into the weeds of a product system, really quantifies the environmental impacts in many different ways. So these are developed using predetermined parameters by your product category. There's no evaluation done. It's not a third-party certification per se. It's providing data to the customer. And what I think of an environmental product declaration is like a label on food. You look at it and you can compare food, how many calories, how much protein, how much, things that we've become very familiar with over the years. And years ahead, we're going to become more familiar with these different impacts, environmental impacts. And this is also third-party certified. So here's an example of an environmental product declaration. Again, it reminds me of a food label, but we have primary energy demand. Has anyone ever heard the term primary energy demand and know what it means? So we have energy consumption in a company, but energy is consumed in producing the energy to provide to that company. So primary energy demand is the amount of energy that was needed to provide to the company and consumed. So there's global warming potential, acidification. These are examples, and these will differ when you go to different product categories. So they're traditionally meant for business to business, and if there's anyone in here from the building sector, I'm sure you're familiar and you've heard the term EPDs because they're very common in the construction industry and with gaining LEED points. In 2013, the United Nations Environmental Program reported that about 40% of the world's energy and resources are consumed by buildings, and about 1/3 of the carbon. So it's very important that we focus our efforts in the building sector. There's a lot of studies out that traditionally say that the use of a building is where the primary amount of energy is consumed over the life of that building, which is quite intuitive. You would imagine that a building is built and that it's used for how many years, 50, 80 years, and that's where the energy gets consumed, and that's traditionally the accepted idea. However, the last few years, and there's been a lot of studies that have shown that more focus placed in the materials end, materials extraction, materials choice, which these would help in the design, can significantly reduce the energy that's consumed over the life of that building. And you can't change that once it's happened and built. So this is a life cycle chain, I should say, similar to the life cycle impact that I was showing earlier, but it's kind of put in a more orderly fashion. So we have material extraction. We don't often think about that when we're using products, that somewhere along the line, materials had to be extracted from the ground to provide our products that we use. And then there's processing of material, component fabrication, assembly, packaging and distribution, use, and then end of use. A lot more companies these days are really focusing on the end of life and finding that it's economically beneficial to them to focus and address that area. So what I wanted to do is just provide maybe some interesting LCA studies that have been done in the past, just to kind of bring it into context and show how different sectors have used this information. This study was done in about 1993 by Franklin Associates, and I wanted to, it was done for the American Paper Institute Diaper Manufacturers Group. I knew I wouldn't be able to remember that, but so wanted to compare a cloth diaper with a disposable or single-use diaper. And the functional unit, which Anahita will get into more later, is when you're doing an LCA, you have to compare two products the same way. You have to normalize what you're comparing. Each of these would be used in different, you need different amounts every day. So the functional unit for a diaper was the production and use and end of life of a diapering system for a 6-month period. You can tell this is an old study. And this is probably, these results are intuitive. So we have the single-use diapering system, the commercial laundering for cloth, and a home laundering for cloth. Probably not surprisingly, the post-consumer waste for a single-use diaper is significantly higher than a cloth diaper, which is, you would expect that. However, what's interesting in this graph is it shows that the industrial waste, what did we learn from the cloth diapering standpoint, is that the industrial waste is significantly higher than the disposable. So as a cloth diapering manufacturer, you might want to look at that and say, how can we improve? Here's water, the water volume. So in contrast to the solid waste, the water for a cloth diaper is significantly higher than a disposable diaper. So which one is better? That's one of the challenges of a life cycle assessment. When going into a life cycle assessment as a company, when you're doing your original objective and purpose of the study, what is the purpose? If it's finding the best solution, that's not always a great objective, because there are trade-offs that are made with every product that you have. Now, if you're in an environment where you're really challenged with water source, maybe there is a clear solution. If you're in an environment where you don't have to worry about water and you have to worry about solid waste, it depends on what's important to you, your value systems, and the environment that you live in. This was a very interesting study, and it takes a little bit to give you a bit of a background. So this is the McDonald's hamburger container. There was a study that was originally done decades ago by the Stanford Research Institute. McDonald's had commissioned them to do a life cycle assessment, and they basically looked at energy and solid waste, and they're comparing polystyrene or styrofoam to paperboard or cardboard. What the Stanford Research Institute originally found was there is a coating that's on the paperboard that prevented it from being recycled. And the styrofoam container could be recycled many times and used less energy in production, and therefore was the less impacting package. McDonald's took their data and began to use this container throughout their stores. And in fact, they launched a public education program to help, and they started the pilot program in the New England states to teach the public how to recycle their containers properly. While this was going on, McDonald's was in a collaboration with the Environmental Defense Fund in looking at their solid waste overall. But because these packages were a very minute portion of their overall solid waste, but because this particular package was a reflection of our society as a throwaway society, this became very important to the Environmental Defense Fund. Why are we using this packaging? It looks so bad. So they commissioned yet another study, and it was actually done again by the Franklin Associates. Now I can get to the next slide. So Franklin Associates performed the same study, looked at energy, solid waste. You can see on the energy, million BTU per 10,000 units, the foam container performed better than the paperboard container. And only where the recycling at low rates did the foam container perform less well in solid waste than the paperboard container. In addition, so here's emissions, atmospheric emissions, pounds per 10,000 units, and waterborne emissions, pounds per 10,000 units. In both cases, the foam container performed better or was less environmental impacting than the paperboard container. Despite the results, the director of the Environmental Defense Fund would not publicly endorse the use of this product because he did not view it as the best environmental solution. So that's therefore their cardboard containers. So again, coming back to value systems, sometimes the data tells you something, but perceptions can really have an influence on the decisions that are made. Lastly, I don't know if any of you are familiar with this study. I thought I'd bring it more close to our day. Levi did this study in 2013 on a pair of Levi's. And they wanted to do it to understand, they wanted to dig into the weeds. Where are our largest environmental impacts? Maybe they're done with looking at each facility and they really wanted to look at the product as a whole. Where are the significant environmental impacts? So they did a full life cycle assessment: cotton production, fabric production, garment manufacturing, transportation, consumer care, end of life, and some recycling. They also wanted to communicate to the public and see how the use phase impacts the environmental impact over the life of a pair of jeans. What they found was that consumer care and cotton cultivation remain the most significant impact areas. And I picked out a couple graphs that I wanted to share with you that I thought were really interesting. So this is fiber production. The first couple of studies that I showed you focused on energy consumption, water consumption, solid waste. Those are outputs that we can measure. Land occupation is an actual impact that is done as part of an impact assessment. Why is land occupation important? Would anyone have any?
We have to grow cotton.
We have to grow cotton, but why is it important to understand land occupation?
So, non-edible. We're not growing food, we're growing cotton. It
Well,
displaces the...
We're growing cotton, it displaces food growing. But even so,
Pesticide use.
pesticide use, there's land occupation impacts in growing corn for ethanol as well. When you take an ecosystem away from its normal, what it was, we're losing those ecosystem services. There may have been a water body there may have been a forest there may be some kind of biodiversity that existed that we're taking away. So that is one reason why this is measured. So what I think is interesting here that would not only have been identified through an entire life cycle assessment is the impact that fiber production has. If a company is focusing only on their operations, they wouldn't see this. In fact, fabric production was only 2% of their impact. So I just think that that's really interesting. It really highlights the importance and what a life cycle assessment can show you. And I thought this was really interesting as well. So we have, it's busy here, these are climate change impacts, so carbon dioxide equivalents. And we have a conventional washing machine and an efficient washing machine. We have washing weekly, bi-weekly, and monthly. I'm not there, I'll tell you that. And then we have washing in warm and washing in cold. And it's really amazing the impact. I was thinking about this earlier. This is doable for most. You see efficient washing machines in many households today. Going from drying your jeans in an efficient washer, in cold, in line drying, you reduce about 80% of their carbon footprint. That's amazing that we could have that much of an impact. I just thought that was really interesting, and it kind of brings it home, the importance or what this data can tell us. So from here, I'm going to pass it on to Anahita. Thank you. Oh, I didn't finish that one. So just to summarize, and I think we touched on this in all of the samples I showed you, there's always trade-offs. There's not one easy winner. It's really important at the beginning of a study to highlight the objective. What is the purpose of the study? What are the audience? Where are the impacts that we're concerned about? Understand those. And same thing, critical to document all assumptions made, define the systems, understand why. And Anahita may say this, an LCA is iterative. A company may get through an analysis and say, wait a minute, we need to redefine this boundary, we need something to look at. And then that's why it can take a long time. And lastly, and we touched on this in a couple ways, that decisions made depend on perceptions and value systems, and again, what's important. So thanks.
Thanks, Kim. So kind of continuing down that path, the primary reason that we've seen companies approach us to help them by actually performing the LCAs has been for two reasons. Either they want to market their product as being environmentally preferable and they have to make sure that they have the data to back it up, or for internal product design, for future design, to really be able to understand the inputs and outputs of their process over the life cycle so they can make changes that will really not hurt them in the future. And now my slides might be a little bit more, they're not as exciting, because I'm going to start getting into a little bit more of how do you actually perform these LCAs? What are the key steps, and what would you have to take on to actually get through the process? So kind of backing up for a minute, though, and talking really about this life cycle approach. Why is it important, right? So Kim touched on that. She showed some examples. And as we're out there in our roles today, we've worked with over 200 companies in New York State, and oftentimes we're working within their box. So you go into a manufacturing process or a food process or whatever the case may be, metal finishing, and they have a system. They're physically in a plant that's processing something, and their company goals or corporate goals or someone's driving them to say, within my box, I have to reduce my environmental footprint. And it's very rare that we've seen people to say, hey, let's really help us, unless they're working on these green technologies. Let's really look at that life cycle. Let's back up and see what are we bringing in that's having an impact. But more and more, I think Kim mentioned, in recent years, people have been interested in what's happening to my product once it leaves. Where is it going? How are consumers using it? And at the very end of life, does it go to the landfill? Does it go to incineration? Can I recycle it? And what is that environmental impact? And that's been really interesting for us to do those LCAs. I'll give you a very high-level example. We worked with a major medical company. They produce medical products in upstate New York. And they were actually developing a new blood pressure cuff with a very different material than what they were used to making. Why? Why did they even go down this path? Because they're a global company, and in Europe, they were asking them, before you can sell your cuff here, what is the environmental impact at the end of life? And they needed to quantify that. So that was the drive, the why. They wanted to do more business globally. And then we were able to model their 3 different designs. The one that they've been selling for many years using PVC as their key material. Their second cuff, which actually had less parts, so it weighed less, but it still used PVC and some mix of maybe polypropylene. And then their third cuff, which was their new eco-design cuff, which had started from scratch, really trying to put in the philosophy of sustainability and designing for the environment. And that material we also modeled. So showing those 3 scenarios, and as I go through my slides, you'll be able to see how you can look at those products side by side. And the label that Kim showed you, that EPD label that had like ecotoxicity and cancer and et cetera, those are the impacts that you'll see for life cycle assessment, and you can compare products and really understand, okay, in one area I may be doing great, but hey, here's some areas for improvement. So for future design, I should focus there. So that's why it's so important to think a little bit outside of the box. And it's difficult because in companies today, there's a lot of pressure to produce more and do it with less people and get costs out. But at the same time, if you put in all that energy into that one box, are you really getting that overall environmental reduction? Maybe not. And I'll show you a case where we actually found this out. Another very simple example of why life cycle thinking is important. So say you have a contaminant or a pollutant, and you want to just get rid of it. So you add a solvent, and now that's gone, it's been dissolved, but now you have a waste stream with a solvent in it, right? So overall, did you really do something to benefit your process? Maybe not. Maybe now you're paying a lot more to get rid of this, solvent in your water. So things to consider is always, what is the trade-off of this change I'm going to make? Just because it might meet one goal, it might really hurt me later down the pipe. Okay, so there's many ways of actually going through and doing an LCA, and I'm not going to sugarcoat it. It's a challenging process at times. It depends on how much data you have available and how much data you're willing to get and how much of a good relationship you have with your supply chain. And then there's a question of, after today, is this exciting enough for you to want to take it on and hire LCA experts? You can't have Kim, but that's what some companies have done. They've built in their own teams. Others have just decided to pick like their largest volume of product, whatever it may be. In my case, I'm going to talk about toner with a major xerographic company, and we focused on their largest product that was going out in the most volume, and they wanted to be able to talk about that from an environmental perspective. And so they picked one and started there, and then decided, was this worth my time, my investment, and made that decision. So there's a lot of ways to go. There's obviously consultants, and then there's opportunities to work with resources as well. So we've talked a lot about LCA, and before I get into the weeds of a full-blown LCA, we wanted to at least tell you that there is a streamlined life cycle assessment. It's much more high level, it takes much less resources, and overall it incorporates the life cycle thinking approach. So the goal of this is really to have more of a qualitative understanding of your process or product than maybe a quantitative understanding. And I'll show you, there's a matrix way to go about doing this. So when I took industrial ecology back in graduate school, Tom Gradle from Yale University is one of the founders. And this basically comes from their book. They developed this streamlined LCA to make it as a good starting point for companies just interested in life cycle thinking. So here's what it is. It's basically a matrix. And all of these 1, 1, 1, 2, this is just showing you where you are in the matrix. That's all it is. You would define a scale that would make most sense for you. So for instance, if you were comparing something as basic as plastic bags that are going to the landfill and cotton bags that you can reuse, like that example, you could just take this, and there's a couple ways that you would set your own scale. So you would define what your scale is. So if in that case, I could say, and I like to use the pluses and minuses. So I would say that 2 pluses means that the single-use plastic bag going to landfill has a significantly more environmental impact than my cotton bag. And then I would put 1 plus means that it has just more of an impact. And then 0 means that they actually have the same impact. It's neutral. And then you'd just make your own scale that way. And then you would basically go through with your team, and you'd look at every single step in the life cycle, which it lays out nicely here. And these are all the key categories. At least it's a good starting point. You may have others to add. So like biodiversity, energy use, solid, liquid, etc. And then you would score that. So in this box for the raw materials, do you think that the cotton bag would have significantly more or less of an impact than the paper bag? And it's interesting, because actually we have an example where we would run through this with all of you and for fun, but we time-wise thought we didn't have time. But it's interesting because people will do this that maybe don't realize like the impacts of the two, and based on perception again, think that cotton's always going to be perhaps better. When we actually run it through the SEMA Pro and the analysis and do the LCA, there's trade-offs at the end of the day. So, but this is the kind of thing that you could do easily with your team anywhere. You wouldn't pick random products, you would pick the products that you know, right? So if you're in the xerography business, you would pick products that you would know, and you'd be able to educate your team, and you'd have knowledge to actually put in good qualitative data. Does this make sense? And if you want anything more on Streamlined LCA, we have an example we could send you. You could try it out and see if you like it. And they even have moved away from just doing a simple matrix like this, and they actually have software that can help you do a Streamlined LCA. So it's becoming more sophisticated. Yes?
So for example, if you were to compare the bags, as you said, for things that say, liquid, I believe it says liquid, does that mean the impact? And then you as a person are assigning a value without any institutional knowledge of how much impact you think that's having on that particular thing?
Right. For fun, you would do that, right? So for plastic bags and paper bags, it's an exercise that we've run with just to show the value of a Streamlined LCA. But hopefully, in your own business, whatever it may be, right, whatever you're producing, you would have a lot more knowledge, right? So whatever the two products are that you're comparing, you would know a lot more, and you'd be able to make more intuitive decisions that make factual sense than just off the cuff, right? Someone on your team works in the supply chain, and they would know, this product probably has a lot more than this other one. So the idea is to do it with some good idea of your two products, but does that make sense? Okay. And at the end, you would just add up. So if you're using these pluses, for instance, say you have like plus, plus, 0, minus, you would just treat them as like +1, -1, 0, and you would add it up, and you'd have a total here. So for each column, you'd have a total, and also down this way. And you could look, again, at kind of your trade-offs. Like, is it solid waste really much greater than biodiversity? Or you could look at it this way, looking at your totals by different life cycle stage. Is my product use really having major impact compared to my manufacturer? So that's the idea. You would just sum up the different matrices and be able to make at least some good initial decisions before you went full-blown LCA. So there is definitely some value, and we actually worked with Kodak some time ago and did more of the Streamlined LCA. It's high level, but you don't have to get into the weeds, and you can make some good design decisions from there. Again, you would not publish this. If you're going to publish anything, you would have to follow the ISO process and do a full-blown LCA, but internal design, these things can go a long way. Okay, so just again, definition-wise too, you bring this back and say, hey, Streamlined LCA versus full-blown LCA. Again, this is much more high level, gives you a relatively high level understanding of your environmental impact, but you can look at it at all the life cycle stages. It's not as quantifiable, it's definitely more qualitative. And you can even consider a portion of the life cycle. You don't have to do the whole thing. If you're only interested in a couple of stages, you can just go through and do those. So much more simple, less resources, whereas now we're going to get into kind of the LCA itself. Okay, so LCA methodology, there's 4 key steps. The first one is probably the most important because, as Kim mentioned, you really want to sit down with your team, ask the questions of the why. Why are we doing this? Because right up front, if you're going to market anything, then you have to start by following the ISO process for LCA. And part of that ISO process means when you're done with all this data, you're done with this analysis, you actually get it peer reviewed. So it goes out to 3 experts, and they make sure that your work is valid and legitimate, and they bring you back any comments, and then you can go out and actually market it. So it's that much, it's very critiqued. So the LCAs that you see out there, they've been critiqued by experts. So there's 4 steps. Goals. First one, defining your goal, defining your boundaries. Are you going to do it from cradle to grave? Are you going to look at it from cradle to gate, as we say, like when it leaves your building and that's it? Are you just going to focus on end of life? These are all just conversations and decisions you would make up front. The inventory, that's the part I'm going to focus on more with my example today. That's kind of like the ones that Kim mentioned to you, where you really look at the quantitative data. At the end, you look at water and solid waste and air and so on, and you can get a good feel for your process. And then impact is the third phase, and the one that is probably, we could do an entire workshop on impact. For today's purpose, I'm just going to talk a little bit about how do you go from inventory to impact and what kind of results can you see. And then at the end, you want to report your results and make some good decisions and move forward. But those are the 4 key phases of the LCA. So again, the first one is, again, one of the most important. These are the key things. Defining your system boundaries. Really, where do you want to draw your boundaries and why? Why is it important to go all the way from cradle to grave? Like I said in that one example with the medical company, they needed it cradle to grave. They needed to see the end of life impacts. That was the whole point of the project. Some people just want to look at material changes up front. So maybe you can go to gate.
I'll just add here too, sometimes the system boundary is defined by how much data you have. Maybe you don't have access to data that you would normally need, and you have to eliminate that phase or shorten the boundaries.
Yep, very good. But you want to be careful, because if you are limiting it too much, you may miss a major part of the life cycle, and if you're using, if you include the whole thing, you may not have the data. So there are challenges, and we spend a lot of time working with our companies on this phase, making sure we understand their needs. So in some cases, these are just, again, basic examples of how you can eliminate some parts of the process. Because in ISO, if you follow the ISO standard in your marketing, if you eliminate any part of your life cycle, you have to be able to back up why. It has to be legitimate. So for instance, in this case, if you want to look at 2 different packaging materials for the exact same product, then you may be able to exclude the actual raw material extraction and the manufacturing of that product piece, because it's the same product. You're focused on the packaging piece. So that you can kind of say, okay, those 2, they're not going to change, so let's just focus on the packaging. So that would be an okay thing to do. The second one is more of a chemical example. If you're looking at 2 ways to make a chemical or to make a chemical process, it's all about the beginning that you're worried about. After you make that product, and how you get rid of it, or the ways that it gets disposed of, may not be in your boundaries. You may just be worried about the upfront of how is that chemical product coming about. So these are some ways that you would have to write down and make your assumptions up front. Okay, so the inventory phase, once you get through the goal and scoping, is the most quantifiable, data-intensive phase of an LCA. It's called LCI, and basically you put all your, if you're doing a cradle to grave, you would write all your process steps, you would draw a boundary around it, and you would look at all the inputs that go into your process and look at all your outputs, including anything that you have to recycle back in. So it's really an input-output mass balances and energy balances. So it's really fun for some chemical engineers, if you have any on your team, to actually go out and try to do this kind of thing. And what's interesting is, I worked at a xerographic company, and my example will be about that. And they do amazing work. They've made products for years. And when I went there as a graduate student, and that's where my study is going to be based off of, they make product all the time, but they hadn't actually maybe gone back into the nitty-gritty of their manufacturing process. We actually did one of their first detailed energy balances around their toner process and one of their detailed mass balances, because their focus wasn't on environment per se, it was on getting product out the door, quality, other things. It took environmental graduate students to come in and say, hey, we can do this for you. So, okay, so just to kind of have this, more for reference, if you're ever going to do an LCI, these are kind of the steps. Again, you're going to do the goal and scope. You're going to make sure that for LCI, you're going to start collecting data. And when you work with a team and you work with resources, they would be able to tell you what kind of data you need at each step in your process. We actually have kind of sheets, templates that we give our clients and say, okay, you need to go back to your suppliers and collect this data. And for your manufacturing, you need this data. So it's laid out nicely. So then you would actually do your process flow diagram. You would actually map out your process, right? You'd have to understand what it is and what's going in and out of it. When you get to data, that's where we actually spend the most time. We have to collect data from the client or within the company. When I did it, you collect a lot of data and you go back and you have to validate it. Does this really make sense? Are you sure this number is not off? And so you want to make sure your study is only going to be good as your data. So you have to just go back and forth there. So you collect it, you validate it. As Kim mentioned, you have a functional unit, because when you do mass balances over a life cycle, everything's in different units. At the end of the day, the functional unit acts as your one common denominator. So it's important you have that discussion. We won't get into that in detail right now. You have your system boundaries, so you're ready to go. So this is what I did as a grad student with a major xerographic company to kind of walk you through goal and inventory. Okay, so this is kind of the example that I'll talk to. And this was actually my maiden name, so if you want to look up our paper, my husband and I married after this, and he was on my team, so we survived this LCA together. So basically, we went into the xerographic company as grad students, and we actually sat in the toner manufacturing plant. So again, the focus at the time was this is my box, and our goal was to reduce the environmental footprint of toner manufacturing. Like, again, just there, not outside. So we said, hey, we'll take a look at this, but let's look at the whole life cycle. We're taking this cool class. We talked about this great tool. Let's apply it. Why not? So they said, okay, go ahead. So we started here. So when I say draw a process flow diagram, this is what I mean, right? This is what toner manufacturing is at a high level. Do you know what toner is? It's the black stuff you get on your hands when you play around with the copier, right? Okay. So again, we picked the highest volume. We started with one, highest volume product that was going out the door. And we said, what goes into toner? Okay, at the time, it was some type of resin. It was carbon black and magnetite. So these were our key raw materials. After you make the toner, this is like what we call gate, right? So you can actually do a life cycle just to end of gate. And then when it leaves, it's usually someone else is dealing with it. But for this, we did the whole thing. So we did to grave. So after it goes on toner leaves, it goes to consumers, and people use it in their copiers, right? So you print. And after that, it can go to some places, a landfill, recycle, et cetera. So that's end of use. So we drew this, and like I said, you draw your boundaries around the whole thing, look at all your mass and energy coming in, waste coming out, and byproducts. So, just to show you the complexity, right? This box breaks down into more boxes, right? So toner, how do you make toner? Well, in this case, this is how you make toner. So again, you want to map these things out. I just want to make sure you have a good understanding of this, right? So in this case, they had raw materials. They, got rid of some of the fines. They heated it up and cooled it. Then they grinded it, so they got it even down. So toner, it's really interesting. You actually start with large particles, and you get down to very, very small particles. They classified it, et cetera. Anyway, we mapped this out. So we wanted to make sure that we understood this process. And I actually had to go walk the process for the energy numbers and look at the pumps and get the horsepower and actually do the energy balance that way because, again, it hadn't been done to that level of detail. So then we picked a functional unit, like we mentioned a few times. It was 1 metric ton of toner produced, and we actually normalized everything to that. Okay, so that was toner. Great. Each of these actually broke down back one step too. I just didn't include it here, I don't think. So like resin, what is resin? It's styrene butadiene. Where does that come from? Right, so each of these had their own boxes as well. And then this part, the consumer use and end of use processing, starts here. So toner gets done, it goes to customers, and then I mapped out the different scenarios, right? Toner goes on paper, you can store it for life, that's one possibility. It can get recycled, that's the de-inking. It can go to, some people don't recycle, they just throw it in the garbage, right? So that's a possibility. So, and then some of the toner, actually, when you're done with it, right, you send it back to somewhere, right? And it gets recycled, at least at this company, it got recycled back into their process. So again, this is the level of detail that sometimes you get into for an inventory. The good news is that you don't have to do this, and I'll tell you why in a little bit. But I think there's a lot of value in this step. Inventory is really important, and I'll show you why. Okay, so as I was doing all that, right, I mapped out the process. We were actually doing mass and energy balances. And if you look at this, this is a big table. Everything here is what's in my process, right? There's the raw materials, the carbon black, the magnetite, the resin. This is the actual toner manufacturing, consumer use, end of use, and transportation. And then all of these are the inventory impacts that we talked about, right? So the actual energy use, the carbon, the NOx, the SOx, VOCs, et cetera. So this was my system. And when you first do your box, toner manufacturing, if you look at these numbers, it doesn't tell you anything really, right? Like it tells you, okay, I use energy, I have some NOx, but what does that really mean in regards to the life cycle? When you fill in the table, don't panic, right? So when you fill in the table, you actually can start drawing some conclusions. Okay, so toner manufacturing, the energy use was say 22. Consumer use, it was 150. So, all right, now I know like something's relative here, like that maybe isn't that large compared to another part of the life cycle. Or let's take a look at end of use processing. Boy, the wastewater and solid waste here, if you look at this line compared to like this line, minimal, resins minimal, 1.5, this is huge. Wow, it really takes a lot to de-ink that toner off the paper. This company, again, for so long hadn't really thought about end of life. Like once they made their product and left, at the time, why is that? That's not someone else is doing that, right? The consumer is dealing with it and then someone else is gonna get rid of that stuff. So this was really an interesting study. It showed a lot, and take all those numbers and put it into a bar graph, you can probably see a lot better, right? So if you look at those, the scale, right off the bat, you can see that the dots, is consumer use, so that the toner in the machine actually has a huge impact. Also, you see the big black lines, the end of use processing, so that actual recycling, de-inking that toner off the paper takes a lot of wastewater and solid waste. No one really had thought about that before. But if we had spent all our time in that plant trying to reduce the environmental impact of just the manufacturing process, that's these lines. They really, overall, don't have much of an impact. So we could have poured our resources, our time, our money, we could have made a little bit of a difference in toner manufacturing, but why, right? Like, we have all this opportunity now to make a difference in other parts of the life cycle. I think that was the big takeaway. We were able to move on in grad school and actually worked for this company professionally afterwards. They were able to see the value of this tool and what it could actually do in inventory. And and so how do they use this? A couple ways. One, they really started to think about end of life, and still the industry. I went to a conference for the xerographic industry like 3 years ago, and they were talking about, if we go towards a biotoner, will that make the impact at the end of life a little less? It turns out recently, I guess, data that I've seen, I've been out of the field a little bit, is that it's not that much better. But that's this is like more for not only that one company, it can help you for the industry. How do we reduce the end of life impact? The other thing is, this company specifically moved away from the way they made toner. They still make it that conventional way, the way I showed you. They also started a new process, a future design, where they actually grew chemical, it's called chemical toner. So they grew particles into the right shape and size rather than started large and broke it down. So that new chemical toner process actually reduces this part, the consumer use. When that toner goes into the machine, it's much more efficient. So they used it for a couple ways, primarily for future design, and that, wow, this really showed us a lot of good use. Does this make sense? Do you have questions on this kind of study?
I have a question.
Yeah.
I guess I like the holistic thinking. The piece that is missing out of here, because it's all environmental impact, is the cost.
Right.
The business has to make a decision,
Yeah.
whether it's going to make a profit for the business.
Absolutely, absolutely. And so I should just clarify, I think, and feel free to jump in. The LCA is one tool, right, and many that's used to make decisions. But it's probably the only tool that can show you this level of detail from an environmental perspective, and then you would absolutely consider the cost of everything. It's just that right now, in the way that it's set up, it doesn't incorporate the costs, but someone else is working on those on your team, right? So we would be bringing this, someone else would be talking about the cost, but absolutely. Yeah.
You mentioned that there are databases available to
Yep.
kind of help streamline some
Yep.
of this.
Yep.
So
I will go into that
Okay,
next.
great.
Yep, I will. Yep.
Can you talk about what it was like to talk to the, resin company and ask them about
Yeah.
their product? Like, I guess that to me seems like the biggest obstacle,
Well, it could be. So back then, we didn't have the database that I'm going to show you that actually now has all this data that Deb just mentioned. A lot of this data has actually been done and put into a database, and that's why we use a tool called SEMA Pro, and it gives you impacts. Okay, so we're almost there. However, to answer your question, we actually did at the time when I did this, went back to the suppliers and asked the xerographic company to help us. Some of them were willing, absolutely, to share. Others were not at all. And the ones that were not at all, we had to go back to like the encyclopedia at the time and actually get like how they made styrene, say, or whatever it was that there were, so we had to make an estimation, and that's okay, because something we won't get into a lot of detail today is, Kim mentioned it too, is when you're done with this whole thing, it's iterative, right? So you actually do a sensitivity analysis. So say I guessed a number for my resin because I couldn't get the data. At the end, you could go back and make a really large number and then see, did that impact my results? If it didn't, then you're okay. But if it did, then you know you have to somehow go get that number. So there is a sensitivity analysis at the end.
Follow up on Melanie's question. How does that impact your certification with third party? I mean, how do they address that? Obviously, there's a lot of suppliers out there that are not going to want to disclose certain information.
Right?
As long as you make a good assumption, is that what?
Well, so feel free to jump in. But so what we do is we make the best estimate that we can, right? So even if you don't know the proprietary information they use to make a polyester, there is this database, which I'll show you, that has a lot of options for polyester. So you would pick one that you think is the most similar to yours, and then you would run your whole model, and then you would do the sensitivity at the end. So if that's one of the data points you're really unsure about, you would go back, like I said, change that number. Does it impact your results? If yes, then you'd have to find a way, go back to your supplier. If not, which oftentimes it hasn't been a huge issue, for instance. Usually the parts that people find very confidential, you can find a way to do a really good estimate and then see how much of an impact it has on your results. And you can still get your certification. So. Okay, so I know not everyone wants to do this kind of study that I did, believe me. And the good news is you don't have to. Now, I'll get there in just a minute. I just wanted to show you real quick, because I'm talking about that specific example. When you go from this inventory, this number data, to impact, which is what Kim showed, right? She showed you that EPD label, which had like these types of impacts. These are all environmental impacts. This is what you typically see these days when you look at life cycle assessments. The inventory phase sometimes I feel doesn't get the attention it truly deserves. Because now you put this into the CIMA Pro model. CIMA Pro is just the tool that we use, and I'll show you it. And you have to do a good job, but it basically shows you these kinds of results, but it focuses on the environmental impacts. So it takes those data, the inventory, and it converts it through equations into these types of impacts. So for toner, just for that one product, you can quickly say, okay, if I was worried about carcinogens, it has some. So maybe I want to go back and think about what was in my toner that had this. If it was respiratory inorganics I was worried about, it might have some. But hey, ozone, aquatic ecotoxicity, no, it's minimal. So this is the impact phase. I know I'm just jumping to it, but I wanted to show you what happens when we actually model this. So bear with me. Let's talk about impact now, okay? So the phase 3 is impact assessment, and that's taking that raw data, that inventory data, the water, the VOCs, et cetera, and it actually converts them to these categories, which are, again, the ones that Kim showed you on the ones you will see as a consumer when you're looking at the EPDs on products. So how does it do that? That's a whole course in itself, right? There's actually a society of professional LCA practitioners that are constantly improving the methodologies of how this is done globally, how it fits into ISO. But the bottom line is there's equations that have been agreed to, that ISO has now said it's okay to use, that are in the model that basically take that inventory and convert it to these impacts. So these are the impacts you usually see when you're talking about LCA data. How does that work? So this is another example to just try to get you through this. Say this is a very basic example of, again, another process flow diagram, a mining process and how it works. This process leads to inventory data, just like I showed you for the xerographic example. But at the end of the day, for instance, if you have heavy metals in your process, the impact, the environmental impact, there's going to be some heavy metals that maybe go to soil, and some of them get released to water. So what this is showing you is that the inventory data, if you're going to translate it into environmental impacts, it doesn't always go to one place. Some of it goes into one part of the world of environmental impacts, and some goes to another. So it basically takes this data, it transforms it into concentrations, and here you have like concentration in soil, concentration of greenhouse gas, et cetera, and then it takes this and actually puts it into those impacts that I just talked about: ecotoxicity, climate change, ozone, cancer, respiratory effects. Those are the ones that you see. And this is all done through mathematical equations. And then what some of the methodology does actually is takes these impacts one step further, and it groups them into 3 core categories: resources, damage to ecosystems, and damage to human health. I know this isn't very easy to grasp the first time per se, but I'm just trying to show you that there is actually a methodology to take inventory data and get to impact. And you don't need to understand all of this today. Let's take a simple example, and I'll show you the CIMA Pro database. Say you want to just look at plywood and particle board, okay? Something very basic. Assume they're the same size, and assume that, in this case, they're both going to the landfill. Okay, now I have these two, I want to compare them. Let's model it. So this is what would happen. This is CIMA Pro, okay? I can't run it for you real time, but I wanted to at least get a screenshot. So if you go into CIMA Pro, which is actually the database and the program that is used to do LCA, this is what it would look like. In here, under processes, all of these, if you click on the plus, for instance here, we're going to wood, right? Because we're looking at plywood. So if you go to wood, all of the stuff in here is data that has been input by people that have done the work that I did for that xerographic company, right? So I did that LCI, I got it peer reviewed, it's a paper, and they put it into the database. So you don't have to do that again. If you want to look at the impact of toner, you just click on a button, it'll be in this database, and you'll be able to pull that up and compare it to your toner, if you were a toner company. If you're looking at materials, right, or board, in this case we're looking at plywood. So in this case, for wood, we'd go to wood, and look, there's a bunch of plywood. So even if you couldn't go back to your supplier, there's a good chance that it's already in the database, and you can pick one of these options for plywood. There's plywood indoor use, there's plywood outdoor use, so you just have to decide which one kind of makes sense for you and pick it. If you pick it and open it, if you double click, this is what it looks like. So this is plywood. It's for 1 meter cubed, that's the volume, and already this is in the database. This is all the materials and resources that are needed to make 1 cubic meter of plywood. And this is all the emissions to the air. So the bottom line is that this database has made everyone's life a lot easier. You don't have to go out and do that detailed inventory. A lot of those things are already in the database. You just have to make sure you pick something that makes sense for you. Yeah?
Who owns the software? Like, how do you get it? Or-
Yeah, so for instance, we purchase it. So companies have purchased it if they want to get into LCA. If they want to consult it out, there's consultants that own it. You know, we have it. So you purchase it. And SEMA Pro is one. There's Gabby, and there's like 4 or 5 different types of LCA software. When I was working at the xerographic company, we actually did an analysis of all of the ones available and picked the one that was best for us.
There is one that's publicly available. The US LCI database through NREL is publicly available for companies.
And we could share that then, right, with the group, the link? Sure. So we could share.
And those numbers.
I just have a question about one. Sorry.
Go ahead.
One question about another one. So we've gone back and forth and looked at Athena.
Okay.
You know, the two there, and so it's okay, right? But I'm curious on your take for it.
For Athena, so I actually haven't played around with that as much.
I did do some work with Athena. I had to go back in and look and actually use their reports if I wanted to use the data. The problem is in Athena that maybe it's different today, you can't get down to this nitty gritty.
That's what our issue was. We couldn't
Yeah.
go down far enough.
It's
into
more of
it.
a black box
Right.
kind of a thing.
Okay.
Yeah.
Is your analysis between the different types of software available as well? Because that's something I'd be interested in taking a look at.
So I did that when I was at the xerographic
Oh,
company
okay.
position, but it's something maybe we could look at. I'd have to.
Analysis in terms of comparing them?
Yeah.
We could
We could look at that.
Because
We haven't done
that's
it in a
one
while.
of the things too, so for an architectural and engineering firm, when we take a look at vertical construction and any of the equipment within the system, we do a pretty extensive LCA for it.
Mhm.
Looking at the architectural materials and product and structural, when we go through and we're evaluating these different software packages, it's a hard sell to purchase them to evaluate it. So if there's resources out there that say, okay, this is what we've compared and the benefits, and you know, that would help skip that step.
Ah, okay. That's very good to know. Okay. Do you have a question? Okay. Okay, so does everyone here use LCA on a regular basis? Okay, because then this presentation, you could be teaching this with
And
me.
keep in mind that between each pieces of software, the inventory may be different, right? The data collected is different, the assumptions made are different, the functional units may be the same, but you have to understand when you go in and dig into this data, where does it come from? Is it representative of the US? Is it representative of a region? So you can kind of dig into where you want your data from, most representative of your process.
How often are they updating the information?
This one is SEMA Pro yearly? Or
I think
EcoInvent?
I think it is yearly. This is the most up-to-date one. So, but I think it's annual. I think. I mean,
I know
SEMA Pro
Gabby,
updates.
I think Gabby is annual as well. They're I don't know about US LCI, I can't speak for them, but the software companies that are out there and selling this software keep it up to date.
So let me.
Is there any, is it all aggregate data, or can you like look at individual vendors? Because I mean, it seems to me that somebody may have
Yes.
radically different processes,
Yeah.
and that's really this is all about, right?
Right.
Trying to find vendors that aren't as harmful
But you
as
can-
the next guy.
Well, I'm not sure if I'm answering your question, but say you want to do your model, and there's something in here that's not meeting your needs, right? And you want to put in your own information, you can customize that. So you can put in your own module into here. You don't have to pull from the database. It allows you to do a custom as well.
In fact, the best data to have is
Real
your data.
Yeah.
Sure, that makes sense. No,
Right? So this software not only supplies you with data, but you build your process in here and you put in the data that you have. That's the best, that's the primary data. You fill it in with pieces that you don't have, and you want to make sure, as you said, you want it to be most representative of the process that you're looking at. That takes time. As Anahita said, the lifecycle inventory process, which is this, takes a long time.
Right. But now that inventory that I did for the Zero Graphic company is in here. So you can actually just press a button and you'll have my good
That's
results.
awesome.
So I'm going to skip to the results because I feel like I'm getting into the weeds of SEMA Pro. But the bottom line is that this is what it looks like if you ever open it up. There is an EcoInvent database, and it has all the different materials. And like I said, these are the categories, right? So if you were looking at glass, you click here and there'd be a whole bunch. Electronics, chemicals, food. So there's a lot of options depending on what your industry is to be able to model things. And in this case, we looked at plywood and particle board. So let me show you what it can spit out at the end of the day. And I'm sorry, these are kind of condensed, but there's a lot of ways you can look at the data. In this case, right off the bat, right, not being able to see any of the details, just looking at green versus red. Red is the particle board and green is the plywood, bless you. You can see right away that the green overall has a higher impact, right? The red overall has a lower impact. This was a very simple example. It usually never comes out like this. Usually the impacts, like one is high, one is low, and you have to make decisions. It's very rare that you get something so simple, but this was a simple example. And then back where I showed you that one model and all these arrows going everywhere, I said you can actually roll it up into 3 categories: human health, eco-quality, ecosystem quality, and resources. Sorry, I can't even see anymore. But those 3 categories, you can actually roll these into these 3 categories and look at it that way. This is what we usually look at, though. It's called a midpoint, and we usually look at these types of impacts. So this is what makes the tool powerful. You could look at 5 products, and you could model them, and then it would show you the environmental impact for each of those categories. You can quickly draw conclusions, even for people that aren't very familiar with the software, to show management that, hey, this new design that we're going towards is going to be a lot better in X, Y, and Z, but we have to work on these other components. Yeah?
Yeah.
Oh, okay. I think we're almost done. So basically the last step, once you go through all that, is reporting, right? Why did you do this LCA? You know. So how are you going to report these results? Are you going to take it back to the design team and make those improvements for future designs? Are you going to market it now? Are you following the ISO process so you're finished and you have to get a peer review? This is very important as well, drawing the conclusions. And what makes it challenging is you're going to have trade-offs, and either it's going to be based on your personal beliefs if you're doing this, your company's, what they value, what's critical for them, or if you're in a region, like Kim mentioned, if water's high importance, then you would value that higher. So the trade-offs of the LCA is what everyone is constantly talking about. How do you make those decisions? And again, so we talked a lot about the LCA standards, so they're out there if you're ever interested in them. And then you can actually become a certified professional. Kim is. We have Kate and Brian back on our team who does a lot of work with companies. So, so when you're looking for someone, make sure they have the certification. And then again, this is the last slide, just revisiting why we use an LCA, right? The benefits, the marketing, the design benefits, the informing decision makers, just so that again, I hope this Zero Graphic example kind of drove it home. You could focus all your resources and time into one life cycle stage, but at the end, you could be making a very minimal impact if you don't look at the whole life cycle of your process or product. So that's all we had today. Thank you for your time, and we'd be happy to talk more about your questions. Are excited about is because we have state funding to help support our programs. We have our engineers, we have our LCA team as well, and through the Green Technology Accelerator, we have the opportunity to perform LCAs for companies and offset the cost significantly. LCAs can be very expensive. It just depends on what level, and so because it's part of our mission to just work with companies, we're able to do that. And we've done it with some really great companies, some large global companies already. So again, it could be small, it could be large, and it's more of just a conversation if you're even interested in the tool. We'd be happy to discuss. Yeah? Yeah?
Can I just ask you one more question?
Yeah.
I know it's not about cost
Yeah.
to the company, but like another gentleman mentioned the last time, that's a company's concern. Is there a way that you could kind of, weigh the functional unit and get like a cost per unit and kind of understand the cost to the environment or those other factors for the suppliers, and then in the gate, like before the gate, like you mentioned, and then kind of what the cost is and the impact once it leaves? Like, do you do that at all, or is that kind of like a separate piece?
No, it's a good question. I mean, Brian Hilton, if he was here, would say that's exactly what we want to do next. His biggest thing with LCA has been, we got to find a way to incorporate the cost. And I know they're working on some methodologies that are trying to do that. It's something that for instance, for us, it's not something that we've been requested to do. That's something that we're very interested in going down the path. I'm sure there's a way to do it. It's just trying, it would be something we would do as a team. It's a good question. Any other questions? I know this was a lot of stuff.
And you went really fast.
We
I
did.
could tell you guys were like speeding through
We
it. So
did.
great job. Thank
Well,
you.
thanks.
Thank you.
Yeah.